Hey, day 159. What's this? It's cocaine, right? What color is it? Let's turn on some white light and check. Ooh, looks red. Maybe. How terrible is this? Maybe a little purple. Okay. Let's turn off this light. Okay. So you can see the red where my fingers are, the purple up here. Let's take it over here into the blue room. What do you see? It should look pretty black. The top might look a little bit blue. Why is that? What's going on there? Excuse me. I just drank it. It was good. So, today we're going to look at why it is that we see the colors in that can the way we do now, which is how we usually see it. Why they look different under just red light, and why they look different again under just blue light. Exploring colors. If I was a YouTuber, this is where my intro would be, but I'm not, so there isn't. So day 159, what's here? We had a Zoom today. We went over some of this stuff, and this will be a little bit different, but mostly the same content. And so we're going to look at how light can only be seen when it bounces off of an object. 5 years old. All right. And describe which filters transmit certain colors and which absorb colors, and we'll see that you can combine a couple colors to affect the color of transmitted light, the light that gets transmitted or passed through. So here's a fun little story for your warm-up. So philosophers, people that think about things and why things are the way they are, often wondered about color and where it came from. And so one common belief was that everything in nature made small particles, like light particles, and that's what reached our eyes, and that's how we saw stuff. If you're looking at a screen right now, well, you are, that screen is emitting light. So kind of makes sense in terms of watching a TV or a phone or something, right? Those things put out light, visible waves. But they didn't have that back then, so they weren't thinking about that. They were just thinking that, I see this red fire truck. All right, this part puts out red particles, and so when I look at them, they look red. This part puts out blue particles, orange, white particles, black particles. They all just put out particles. So the issue with that, and there are some, all right, is that, it's not true. So why not? Their belief's not accurate. Why not? Think about why not. And then try to answer the other questions here, and then come back and we'll talk about them. So pause now. Okay, and welcome back. So, not true. I forgot to wear a red shirt today. I got blue on, but we got a red fire truck, and so we can see it. Would this thing be making red particles all the time if this hypothesis was true? Like, what if it was nighttime? Would it make red particles then? If it did, what would happen? If this made red particles at nighttime and emitted them all the time, it would make sense that you would see this just the same way at night as you do during the day, because it's the same truck and it should continue to emit the red particles. And somebody might say, oh, well, during the daytime when the sun hits it, it heats it up and gives it energy, and then it gets rid of some of that energy by emitting light particles. Kind of like when you heat something, then as you let it cool, you feel it radiating. So there were lots of ideas for how to deal with some of the problems with this concept, and the idea that things decay over time, and maybe that's because the light particles are leaving, and so things get old and worn because some of the particles are leaving them. Turns out not true, though. Light, what we see, comes from reflections. So whatever you put in affects what you get out. And that's what I'm going to show you today. I'm going to show you that adjusting the light that goes in to be reflected off an object affects what you're able to perceive with your eyes. So if I had this red thing or this blue thing, and I turned the lights off and the room was totally dark, what color would a red shirt, a blue shirt, or a green shirt appear? And the answer is blue. Just kidding. What you're seeing right now is because the screen is on. But if I turn the screen off, turn it down very low, you can see my shirt begins to appear black. And the more I remove my shirt from the light from the screen, the blacker it gets. So all these things would turn black. Oh man, too many burps. Whew. There we go. Okay, so colors. How do they interact? We're over on Schoology. If you can't get to Schoology, here's the backup link. You can upload that later. Boom. 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 All right, there we go. Third boom did it. All right, some people are on here now. Anonymous Tiger and Anonymous Anteater. Good for you, Anteater. The tiger is idle. Instructions for how to do this right here. Very brief. 17 seconds of just talking about how you can combine light colors and what that looks like.
The triple light RGB bulbs on the right. The sliders on the right let you adjust how much light is being emitted from the bulbs. Record your observations in your lab. You can mix them up by adding what you want and seeing how that affects what colors we see.
Mind blown. Okay. So some questions down here to help you think about and dig deeper into what you see. A fun thing to do with that RGB, by the way, RGB stands for red, green, blue. So a fun thing to do with that little simulator is to not just go full for all three colors, because that's just going to get you plain old white, but to mess around a little bit like I did here with a little bit of one and some of another. Just try like varying the amounts of two different colors. And then also, it's frozen. And then also you can do 3 color mixes, but try just 2 color mixes first. And don't do them both full. Do like 1 full, 1 half, 1 full, 1 a quarter, right? Like down here. And then, just try and mess around. Try to make some different colors that you're used to seeing. All right, we'll just refresh. All right, so that's RGB and lots of questions to answer, like what happens when you combine red and green. Ooh. Nope, I don't have red and green. Orange and green, I think. Is that red? I can't tell. I think that's orange. So you can play around with some of this stuff at home, which is why I brought this in here. And there are better, not all of this stuff gets picked up on here, but there are lots of ways that you can make your own filters, and I'll get to that in a sec. I'm getting ahead of myself. Okay, so what happens when you combine these different colors? Just answer those things, and then try and come up with some rules for color addition. So basically, like what happens when you add together 2 of these things? What do you get? What happens when you add together 3 of them? What do you get? There's different rules, different combinations. Like when you add together red and green, you get something. When you add green and blue, you get something. When you add blue and red, you get something. And when you add red, green, and blue, you get something. That's basically what the 4 rules are. So write those down. The 4th one's down there on the 2nd page. Sorry. And then we'll use what we used yesterday, which is this, where you just have the single light source, but it produces a variety of colors. And we'll use that. Let's see if it's loaded yet. Nope. Still thinking about it. So we'll use that. and use filters. And the cool thing with filters is you can block certain types of light. So earlier, I showed you some different lights up here. Let me turn off the white one, because the white one produces all across the spectrum. And so this red one up here, see if we can get it to focus a little bit. I think it's too intense. Now you can see it. So it's got LEDs. It's got 4 LED strips. These are red. The one in the closet there that's blue is the same thing, just it's blue. And multitasking. And so these produce just pure red light, and that's pure blue with no mixing. And so let's see what happens. I'm going to take, remember this fire truck? So that's blue. Yeah? Let me close the door. And you can see that what once was blue is now what color? It's black, right? We can see that the red still appears. That which was white is still fairly white, sort of white-ish. The orange looks red now. Here's a blue pen. And part of why you're able to see some blue here is because of the white screen on my machine. But now it appears black. Turn down the brightness. So I got these on July 5th because on July 4th, it's red, white, and blue. July 5th, all that stuff has to go away. Got them for $1 or 80 cents. In here, we did the thing with the Coke can. I can also show you some other stuff, like, let's turn the light back on. What's this? Fire extinguisher. Usually keep this in the kitchen. Let's turn the light off. And with the red lights on, it still appears red. Turn the red lights off. And you can see it's already turning black. If I go in here, where there's no white light or very minimal white light, it's black. But it's not black. The reason it's black is because all that's getting shined on it is blue light. Oh, I was looking at the fire extinguisher like I was talking to that. I'm supposed to talk to you. So all it's getting is blue light, and it only reflects red light. So if there's no red light to reflect, it just reflects nothing, and it appears black. So you can mess around with the filters. You can put a filter right here. You can see what gets absorbed and what gets transmitted. I gave you an example. If you take some red light, like I had behind me, and you apply a blue filter to that, then the blue waves get filtered out and no light gets transmitted through. This is basically what happens with this, right? Instead of a blue filter, we're just actually applying blue light. And so we don't see any transmission. Okay, so you can try different colored filters. You can play around. There's infinite filters to try, and just explain what you see, and that's it. That's the whole activity. You can make your own filters if you want. So you can take a piece of tape, all right, like this, and rip it, and then you can fold it in half and stick the sticky to itself. And then you can color a little bit on here. I've got some red. And I'll put a little blue line next to it. And then you can do all kinds of little stuff with this. You could take a picture with your phone. So you can apply the filter and it will filter out colors. And if you do this right, or with the right kind of tape, or it works a little bit better with something that's clear, but you can see that some of the blue and the red are showing up on my phone. You can do some pretty cool stuff. And that's a simple way to make a filter. And you can also use the flashlight on your phone, this guy right here, with one of these where you just make it one color, and then you can just shine that. It helps to do a couple of layers, to have a few layers to really filter out the other wavelengths of color. But you can do all kinds of cool things. And yeah, this is one that somebody sent me. It's kind of neat, right? A little bit of a filter. So cool stuff that you can do with color filters. And that's it. All right. That's all I got. Have a great day. See you tomorrow. Toodles.